All right, so today what we're going to look at is finishing up section, chapter 2, okay, with section 2.5, and then we'll do a little bit starting in 3.1, and we'll see how much we get through. All right, so we're going to look at a projectile motion problem. Okay, we've done this before, but I'm going to put the formula up again just to remind you. So for projectile motion, this is a formula that gives you the height of your object after a certain amount of time has gone by. So t is time. V sub 0 is your initial velocity. So it's basically when you throw your object, how fast you're throwing it. S sub 0, can't see it, but that is your initial height. So if you were throwing something off the top of a building, the height of your building could be your initial height. I guess technically if you were throwing something like a baseball pitcher, they don't throw from ground level and they release it. The ball is probably 3 feet off the ground. I don't know, roughly maybe. Okay, but there's our formula. So we're going to take that formula and we're going to use a graphing calculator to solve this question. So we are going to throw a ball straight up from ground level with an initial velocity of 80 feet per second. So Brandon, where is that 80 feet per second going to go?
It goes at the height. Oh no. Initial velocity.
It goes to the initial velocity.
Yeah.
Right. V sub 0. Eric, that sentence tells us something else about one of those variables. What else do we know from just reading that sentence?
Initial height, or initial height 0, is that what you just said?
Yep, initial height is 0 because you're throwing it from ground level. Okay, so let's fill in everything that we've got. So S equals negative 16t squared plus v sub 0t. In our case, is 80t. So there's a formula that will tell you how high this object is going. Any questions on the formula? Now, we're going to use that formula to figure out when the ball is at least 64 feet above the ground. So, what does that mean? If I ask you when the ball is at least 64 feet above the ground. What does at least mean? Yeah?
Greater than or equal to?
Greater than or equal to. So the question is, when is the height greater than or equal to 64? So now what do we fill in for height? We got a formula right here. The height is negative 16t squared plus 80t. So we're going to graph that and see when it's true. Okay. So what you want to do is take what's on the left, put it in y1. Take what's on the right, put it in y2. And you're going to look for when what's on the left is above or equal to what's on the right. Okay, let's take a look. All right, so we've got negative 16x squared plus 80x. I could have done y1 and y2. I accidentally did y2 and y3. Whatever, it doesn't matter. I'm going to do zoom 6. Okay. Is that a good window? No. When I put y equals 64. That's a horizontal line up at 64. So I've got to go at least that high. And we don't know how high the ball goes. Let's just put in 110 feet. If the ball goes higher than that, it's going to go off the screen. Do negative values make sense for y? No, y is height, doesn't make sense. What is x in this problem? I had to change my variable because it's what the calculator uses, but x was originally which letter? Time, t. Can time be negative? No, that doesn't make sense. So there's our object. There's a line at 64. We're basically trying to figure out when it's in this top section. Okay, so what do you think I'm going to have to calculate here to figure that out, Zach?
The first intersection x minus the second intersection then?
So if we wanted to know the time that it's above 64 feet, like for 3.5 seconds, then you'd subtract them. We just want to know not the duration of time, just when, just the time itself. So like between 1 second and 3 seconds, or whatever it comes out to. Right, but yes, if you wanted the duration, just subtract them. Okay, I'll do the one on the right. If someone else can do the one on the left, that'll help us out. So on the way back down, after 4 seconds, the ball is back below 64 feet. So the time has to be less than 4 seconds, but more than how many seconds? 1. So between 1 and 4 seconds, this object will be above 64 feet, and the duration of time that it's above 64 feet, which they didn't ask you, but it would be 3 seconds. That's how long it'll be up there for, above 64 feet. Okay. So any question on how we did that? Definitely something we could have done using algebra, and we will eventually. All right, so now, kind of like the question Zach answered, but I don't want to know when the ball is above 64 feet, or how long it's above 64 feet. I just want to know how long it's in the air, period. So what does that mean about the height of the ball if it's in the air? You know that the height has to be what? Zach?
Greater than 0.
It's got to be greater than 0. So we're going to set up the same equation we just had, except instead of the height being greater than 64, do greater than 0. Don't do equal to 0, because when it's equal to 0, the ball is back on the ground. It has to be greater than 0. Okay, now we're going to learn in the next part what a sign pattern is. Basically, the only way to solve a quadratic equation is to factor it. You have to be able to factor this. Does anybody see what you can factor out of both terms on the left? Yep.
8.
Even more.
16.
Even more.
Oh, 16t.
Okay, and I'm going to do one more thing. I'm also going to factor the negative with it. So whether or not you factor the negative, that's up to you. You don't have to. But I'm going to factor out a negative 16t. What does that leave me with for my first term in parentheses if I factor out negative 16t?
T.
Just t. Distribute it and check. Negative 16t times t. Yep, negative 16t squared. And how about here? Yep, minus 5. Okay. Now, we've done this kind of thing before. Something times something is greater than 0. Okay, we had a question kind of like this in the homework. What's one way you can multiply two things together and get an answer that is greater than 0? A what times a what? Yeah?
Negative times a negative.
Sure. Could have a negative times a negative. What else? Positive times a positive. Only one of these situations is going to make sense here. T stands for what again? Time. Time is always what kind of number? Positive. Remember that. Time has to be a positive number. So if you fill in a positive number right there for time and multiply by negative 16, this is always going to come out what? Emily? It's always going to come out negative. You don't have any choice. Time is always positive, and a positive times a negative 16 is always negative. So this is going to be the situation that has to happen. The only way you're going to get something that's greater than 0, given that this is always going to be a negative, is if this also comes out to a negative. And then a negative times a negative will give you a number greater than 0. So the question now is, if you can tell me when t minus 5 comes out to a negative, multiplied by this, which is a negative, it'll cancel and come out positive. So when is t minus 5 negative? Yep.
Less than 5.
Yep. Add 5 to each side, and that's how long the ball is in the air for. So what does that mean? Well, it means it's in the air like 4.9 repeating seconds. 4.9999999. It approaches 5 seconds in the air. Okay. And the only reason we could solve that is because it factored. If it didn't factor, we would have to use a calculator to figure it out. So, any questions on how we figured out how long the ball is in the air for? Okay. So, we're going to look at what's called a sign pattern. So a sign pattern is a tool that you can use to solve a quadratic inequality. That's what you use it for. Now, if I gave you this, that is called a linear factor. It's linear because it's just a variable, could be plus or minus a number. What number could you plug in for x to make that expression 0? Negative 4. Is there any other number you could plug in to make it 0? No, and that's the whole point of a linear factor. Every linear factor is equal to 0 at exactly one value. There is only one number you can plug into a linear factor to make it 0. Now, Jared told me 4 was the negative 4 was the one number you could plug in right here. So think of negative 4 as kind of like the dividing point. Right? If I plug in numbers less than what Jared said, I'm going to get a certain kind of answer here. If I plug in numbers more than what he said, I'm going to get a different kind of answer. And by a different kind of answer, I'm talking about either a negative or a positive answer. That's what we have to be able to figure out. So here's, well, one kind of the same and one different. 2 more linear factors. This factor is 0 if you plug in 1. The bottom factor is 0 if you plug in negative 4. We already did that one. Okay. So that's going to be step 1 for solving a quadratic inequality after you factor. So I guess factoring is step 1, technically. And then step 2 is to figure out what number makes your factor 0. Now the next step, we're going to draw our number line. On that number line, you're going to go like this. You're going to mark the 0. In this case, it's at t equals 1. So mark that on your number line. What you've just done is you split your number line into 2 sections. You've got a section to the left, you've got a section to the right. I want to figure out what the sign is in each section. So the way you do it, ask yourself, okay, what if I plug in a number somewhere in the left section? Pick one. 0. That's an easy one. If you plug in 0 into the formula t minus 1, what kind of number do you get? Positive or negative? Eric?
Negative.
You get a negative. Any number that you plug in to the left of 1 will give you a negative. Now let's try a number bigger than 1. 2. Doesn't matter. Pick anything you want bigger than 1. If you plug in 2 into that, what kind of number would you get? Positive. So what we've just done is we made a sign pattern. Right? And that is going to help you to solve quadratic inequalities. Okay, there's one more step, but I'm going to write that step when we actually get to it in a problem. So you might want to leave maybe 2 lines, 3 lines to write the last step. It's up to you. But I'm going to write down this last step after, so I'll come back to this. Okay, so let's see if we can solve this quadratic inequality. Okay, what did I say the first step is? You can only solve it using algebra if it what? Yeah.
Is it quadratic inequality?
If it's a quadratic inequality, how you can only solve it by hand if you can do what to it? Yeah. You have to be able to factor it. If you can't factor, then everything I'm showing you right now is not going to work. All right, so we're going to factor. Brandon, when I factor that, what's going to be my first term in each set of the parentheses?
X and X.
X. Well, X and X would give me X squared.
2X.
2X. Good. 2X and X gives me 2X squared. Eric, what about my signs? Both positive, both negative, one of each.
Positive and negative.
Yep, positive and a negative. He said positive, negative, I wrote them in that order. That could be wrong. You might have to switch them. And now 2 numbers that multiply to give me 5. And subtract. Yeah, so 2 numbers that multiply to give me 5. Oh, Chris?
5 and 3? No.
That's 15.
5 and no, never mind.
So 5's prime, so there's only one way, I mean, unless you're going to use fractions, but we don't use fractions with this. Yep.
5 and 1.
5 and 1. Okay. I'm not going to put them in that order because, well, you'll see why. I'm going to try 1 and 5. Okay, let's check it. 2x times negative 5, it's a negative 10x. 1 times x is plus x. Negative 10 plus 1, is that plus 9? No. So what do I have to switch? Yeah?
The positive and negative.
Yeah, I should have done positive and negative. And now 2 times 5 is 10, negative 1 times x minus x, 10x minus x is 9x, perfect. All right. All right, so now we've got our factors. Questions on that part? So now there's different combinations of things that could happen here, right? So we're going to make a number line and look at all the different possibilities. 2x minus 1 could come out positive or it could come out negative. I need to know where. X plus 5 could come out positive or it could come out negative. And I need to know where. So let's start with this one. What could you plug in for x here that would make that 0? Just think about setting that equal to 0 and solving it. How about Jacob? Can you tell me where that would, what the root would be for this? 0.5, yeah, or 1/2. Yep. And how about the root for x plus 5? Emily?
X equals negative 5.
Yep. Now these number lines are not to scale. They're two separate number lines. All right. Now you're going to ask yourself the question, what happens if I plug in a number smaller than that? What happens if I plug in a number bigger than that for each one? Okay, pick a number smaller than 1/2, plug it in right here. What kind of answer do you get? Yep.
Negative.
Negative. Pick a number bigger than 1/2, plug it in. What do you get?
Positive.
Positive. They always alternate. The way we do them, one's negative, one's positive. So once you find one, technically the other one is just the opposite. But I would check it, just make sure you didn't mess up. Okay, plug in a number smaller than -5. What kind of answer?
Negative.
Negative. Pick a number bigger than -5, like 2. Plug it in here. What do you get? Positive. Okay. So now we've made our sign charts for the individual factors. The last step is to combine those two into one number line. So instead of having two separate number lines, let's get it all on the same number line. And by doing that, now we can look at the product or quotients. In this case, this is a product. This number line, 2x minus 1, times this number line, x plus 5. So we're going to multiply them together. Okay, and I'll show you how that's going to look. Okay, so combine your results into a single number line.
Oh, can you go back up first?
So the first step is draw your number line and mark all the roots on the same number line. So if I put both of these roots on the same number line, Chris, how many sections am I going to be breaking this number line up into? Well, we had 2 up with each of these. All right, let's just go ahead and do it. So we're going to have -5. We're going to have positive 1/2. So how many sections do I have on my number line there? Emily? 3. And they are going to alternate, negative, positive, negative, or positive, negative, positive. One or the other. So technically, once you find the first one, you're good. But I always find the first couple, just to make sure. Okay. So now we're going to focus on, we'll call this section 1, section 2, section 3. You don't have to call them 1, 2, 3. I just did that. So let's look at what happens in section 1. That's when you're in the less than -5 zone. Okay. Let's look at this number line. In your top number line, if you are less than -5, what section are you in? Negatives or positives?
Negative.
Negative. You're like over down here somewhere. So that's a negative. So that means you'd have a negative times a, now let's look at less than -5 in the other one. What if you're in the less than -5 in the bottom one? What section are you in?
1.
Yeah, you're in the negative. So if you pick a number less than -5, you're in the negatives in this one, you're in the negatives in this one, and a negative times a negative would give you a positive. Now we're going to look at what happens if you pick numbers between -5 and 1/2. Let's start with the top one. Okay, so Brandon, if I pick numbers between -5 and 1/2, would I be in the negative section or the positive section?
You'd be in the negative section.
Yeah, -5 and 1/2 is like right in here. So you're in the negatives. Okay, Eric, if I pick numbers between -5 and 1/2 in this one, am I in the negative section or positive?
Negative.
So where would 1/2 be on this number line?
In front of -5 on the positive section.
Yeah. So 1/2 might be over here somewhere. So if you pick a number between -5 and 1/2,
You'd be in the bottom.
you're in the positives. So between negative and 5.5, you're in the negatives here, you're in the positives here. What's a negative times a positive? Negative. Now let's look at what happens if we pick a number bigger than a half in both sections. Okay, so Jacob, if I'm in the top one, bigger than a half, what section am I in?
Positive section.
Yep, positive. Okay, Nikara, if I'm in the bottom, x plus 5 one, bigger than a half, what section?
Positive.
Positive again. Positive times a positive is a positive. So that's what we're going to use. We've basically done like 90% of the work. Now we just need to write our final answer. Okay, look at the original question. The original question was this. Do they want to know where that inequality is in the positives or in the negatives? Positives. They want to know where it's greater than 0. Where is it greater than 0? Here
Less than 5.
or here. 2 sections, right? So either, and this is how you write it as an interval. You can pick any number from negative infinity up to negative 5. Now I don't remember if it said equal to or not. It didn't, right? There is no equal to, so it's a parenthesis. Negative infinity up to not including negative 5, or you can pick a number from 1/2 to infinity. Another way to say it, a number less than negative 5 or greater than 1/2. And that's the answer. Okay. Any, we'll try one more of those, but any question on that? If you break it down the way I showed you and make the sign pattern, it's not that bad. If you just look at this and try to guess numbers for x, you know, it's kind of hard.
That's pretty nifty.
Yep, so you're just kind of looking at where things are positive and negative. Now, this is a cubic. Cubics are harder to factor, so I've already factored it for you. So you're starting at this step. Well, okay, a little slow. So you're starting at that second step. So you're already ready to make your number lines. This time you're going to have 3 of them. Okay. Let's look at the first factor. Elias, what number would you plug into the first factor to make it 0? Yeah, just 0. Chris, what number would you plug into the second factor to make it 0?
Negative
3.
-3.
Again, I'm just putting the number right in the middle. This is not to scale. And Sam, what number would you plug in to make the third factor 0?
1.
1. All right, now we just have to examine the behavior on each side, figure out where the negative section is, where the positive section is. And if you're thinking, well, isn't negative always just to the left and positive always to the right? In general, if x is positive, yes. If I did this, that would reverse everything. Now when you plug in a negative for x, it's a little different. All right, let's look at that. So Caleb, if you plug in a number smaller than 0, this would be what kind of answer?
Fraction for
So what are my 2 choices?
oh,
Negative and positive, that's it. So if you pick a number that's smaller than 0, negative, bigger than 0, positive. Emily, plug in a number smaller than negative 3. What would you get right here? Bigger than negative 3? Positive. And same idea here. Pick a number smaller than 1. Pick 0. Plug it in. You'll get a negative. Bigger than 1, you get a positive. Now, we're going to combine that into one number line. How many sections is my number line going to have? 4. And they're going to alternate. So let's just do the first 2, and then we'll know what happens from there. These are not spaced. These are not spaced to scale.
Do they always alternate or?
They always alternate. Yep. Okay. So, and we're multiplying. This times this times this. So let's check the less than -3 section. How about, Brianna, if I am less than -3 on the top number line, what section am I in? Yeah, I'm in the negatives. If I am less than -3 on the middle number line, Brandon, what section am I in?
You're less than -3 on the middle. You're negative.
I am negative. Eric, if I'm less than -3 on the bottom number line, what section?
Positive. Or less than negative.
You're in the negatives. Right? What is negative times a negative times a negative? Negative. So the next section, we'll check this one, should come out to be what?
Positive.
If it comes out to be positive, then we'll just say the other two are negative positive. So between -3 and 0. Jacob, in the top one, if you are between -3 and 0, what section are you in?
The negative sign?
Yep. Chris, if you're between -3 and 0 in the second number line?
Positive.
Yep, just barely in the positives. And Jared, if you're between -3 and 0 in the bottom number line?
Positive.
So -3 would be here, right? 0 would be here.
Oh.
You're in here somewhere. That's the negative section. Question on that, between the negative and positive section? And now what's going to happen here if you multiply all that together?
Positive.
You'd end up with a positive. So this is negative, this is positive. Okay, and now the original question. When are you greater than or equal to 0? Elias, how many sections here are greater than or equal to 0?
Not sure.
Chris?
2.
2. Greater than or equal to 0 means you're in the positive section. So you're either there or there. I don't know why I had an extra, I accidentally drew an extra mark. Okay. Anyone think they can describe those two intervals for me? From what to what? Let me scroll back up real quick. Keep this in mind. You can equal 0. Jared?
So it would be bracket -3 to 0 bracket.
Okay. Or
Bracket 1 to infinity parentheses.
perfect. So you can pick any number from -3 to 0, including -3 and 0, or any number that's bigger than 1, or equal to 1. Okay. Any question on that one? So that's called a sign pattern. All right, now I'm not going to go through this one because the rules work the same. A negative divided by a negative is a positive. Positive over positive is positive. The rules work exactly the same as for multiplication. But what's one extra thing you would have to be careful about with division? And we've said this a lot of times. Yep.
Dividing by 0.
You can't divide by 0. So, even though this says, yes, you are allowed to equal the root, you're not allowed to equal the root if it would cause you to divide by 0. So when you find the root here, it's going to be -2.5. you can never equal negative 2.5. So if negative 2.5 is one of your numbers in your interval, do not put a bracket on negative 2.5. That would cause you to divide by 0. No good. Okay? So that's the only thing that's a little tricky with division. Don't include a number that would cause you to divide by 0. Other than that, this problem is exactly the same. You'd really do this exactly the same way you would do this. There's no difference in the approach to how you'd solve either of those problems. And we just did one like that. Right here. So, last part of this section is if you can't factor it, you can't do a sign chart. Okay? So the only other way to do it now is to graph it. So let's try one with graphing. Okay. Yesterday I gave you guys 2 methods when you do a graph. You can leave it like this and put what's on the left in y1 and put what's on the right in y2. Or, does anybody remember the other way you can do it? It requires a little bit of work right here, but then you don't have to graph 2 separate things. You're only going to graph one thing. Yeah. So that's one way. Or, yeah.
Move all your numbers to one side.
Yeah, move everything to one side. And then basically what would you have on the other side?
0.
0. Let's do that. X cubed minus 2x squared minus 7x plus 6. Okay, so now I am going to graph that. And then I'll put the picture, I'll put it in the notes so we can see it. If you got anything else, just go ahead and clear that out. So x cubed minus 2x squared minus 7x plus 6. Okay, I'm going to do a standard window, and I don't know, we'll see how it looks. It's okay, that'll work. All right, so let's put this here. And we're looking for where that graph is above 0. Okay, so what I'm going to do is I'm just going to make this graph different colors so you can easily tell me what I'm looking for. Let's make that section red. We'll make that section green. We'll leave that blue. And we'll make that black. Okay. So can anybody tell me where this graph is greater than or equal to 0? Which sections? Brianna? The green and the black. So in order to, because we can't write the green and the black on like a test, we have to put numbers. I have to find this, this, and this. What are those 3 things called? They're the,
X-intercept.
Yep, they're the x-intercepts. We could also call them the roots or the zeros. So second calc. These are the numbers that you would have gotten very easily if you could have factored it. Okay, but we can't. So we're just going to find them. Second calc 0. Pick a point somewhere to the left. Pick a point to the right. And do your guess. Okay, so we get 1 at about negative 2.26. Is there any question on how I did that? Okay. If not, then I'm just going to call this one B, and I'm just going to call that one C. You would have to find B and C on the calculator, doing second calc 0 2 more times. So, I'll describe the green interval, and then I'm going to ask someone to help me with the black. From negative 2.26 to B, I am above 0. Including negative 2.26 and including B. how would you describe the black interval? Brandon?
I don't know. I just got back.
Oh, you just got back, that's right. You just got back. Anyone help him out? How would you describe that black interval? It's going to be unbounded, right? It's not like B to C, or it's not like this one. It starts somewhere and it stops somewhere. This one's not going to stop anywhere. Yep.
B bracket C, infinity.
Yep. Again, you just find B and C on the calculator, but that's your answer. Okay, so it's really not that bad when you have to graph it and you can't factor it. You just use the second calc 0 on the calculator. Okay, any question on that? Definitely the hardest thing we're doing today, section 2.5. Okay, so last thing we'll look at, and we're just going to touch on it a little bit, is polynomials. So chapter 3 is all about polynomials. Okay, so remember, polynomial function looks something like this. You could have something like 8x to the 4th minus 2x cubed plus 4x squared minus 7. Okay, that's a polynomial. In general, it looks like that. Okay, so don't freak out and get nervous when you see that. It just means you have a term with a highest exponent, then the next one is a lower exponent, and then the next one, eventually you get down to one where you just have an x, and then eventually you get to one that has a constant. Now, it is possible that you skip terms. Like this one skipped the x term. I didn't put it. That's okay. Not every polynomial has every single term all the way down from the highest. Okay. But the important thing to remember is that anytime you have an exponent, it has to be a non-negative integer. 2, 4, 7, 1, 5. Those are all non-negative integers. There are no decimal exponents in polynomials, ever. No decimals. There are no negative exponents in polynomials. Okay. All your exponents are non-negative integers. And all the numbers in front of the variables, like 8, -2, 4, -7, those have to be real numbers. No imaginaries. Right, so you'd never have a polynomial with something like this. That is not a polynomial. 3i is an imaginary number. No. The numbers in front have to be real. Okay, and polynomials are what we call continuous. Okay, we're going to talk a little bit more about that tomorrow. But the simple way to explain it is when you draw it, if you draw it, you never have to lift up your writing utensil to draw a polynomial. It's connected the whole time. Okay. So, as long as your leading coefficient doesn't have a 0, then the highest exponent in the front, we call that the degree. So if you had something like this, the degree of this polynomial is the highest exponent. So Eric, what's the degree here?
8x to the 4th. Or you just mean the exponent alone?
So the degree means just a number.
So 4.
4. So this is a degree 4 polynomial. Now, what if I did this? What's the degree of the polynomial now?
3.
3. Why would you even write 0 times x to the 4th? It's like that's not even there anymore. So don't say that it's degree 4 because there was a 0 in front. Okay? Also, you've got to be careful they don't do something like this. What's the degree there? 5. A lot of people just look at the first term and say, oh, 3. No, it's the highest exponent, which should be the first term. If you're writing it properly, what we call descending order, you should put the negative 8x to the 5th in the front. Okay, but that's the degree. Now, some of these have special names. What do you call a polynomial when the highest exponent is a 1? Think about it would be something like this. What is it? What if you drew that? What shape is it? 3x plus 2. It's a line. So a polynomial of degree 1 is linear. How about a polynomial that's degree 2? Yeah?
Parabolic.
So the shape of it, when you graph it, is a parabola. But the equation itself is called a quadratic. And then if you had a degree 3, that's a cubic. If you had a degree 4, I didn't write that one, but does anyone know what a degree 4 is called? It's called a quadratic. And then beyond that, I don't know any special names. Like if it's a degree 7, you just say that it's degree 7. Right? But these 3 are used quite a bit. Now, think about the domain for a second. Here's a linear polynomial. What numbers are you allowed to plug in for x there? Yeah.
All numbers.
All numbers. You can take any number you want and then triple it and add 2. Okay. How about here? What numbers are you allowed to plug in for x there? Yeah, all real numbers. There's only 2 things you're not allowed to do with domain. You're not allowed, what's one thing you're not allowed to do? Yep.
Have a negative.
Where? In general, negatives are fine, but not if they are
Below 0.
yep, under a square root. So you can never take the square root of a negative. You'll never have square roots in polynomials. You'll never have a variable with a square root, ever. So you don't have to worry about that. And what's the other thing that causes a problem with the domain? Yep. That means you'd have to have a variable in the bottom of a fraction. And you will never have that either. So the 2 things that could happen to cause problems in the domain never, ever happen with polynomials. So the domain of every single polynomial is all real numbers. Now the range depends. There's no answer, there's no set answer for that. But the domain is always all real numbers. Okay, so here's some examples of cubic functions. Here's 4 different examples. The big idea behind a cubic, and we're going to talk about it more tomorrow, is one side goes down, one side goes up. Just look at those. In fact, that's true for any odd degree. The number of twists and turns it can take is 1 less than the highest exponent. And I didn't say the number of turns it has to take. I said the number of turns it could take. Right, so a degree 3 can turn 2 times. How about a degree 4? How many times could that turn?
3 times.
3 times. So potentially you could get something like that. Could. You don't have to, but you could. There's 1, 2, 3 turns. Big idea behind a fourth degree polynomial or any even is they always have the same behavior on the ends. This one is up, up. Odds always have one of each. Down, up, down. You could also have that flipped over and have it look something like that. Down, down. Okay, so page 143 shows you tons and tons of pictures of these if you want to see more. I'm not going to draw a fifth degree, but how many times could a fifth degree turn? Could turn up to 4 times. Okay. So here's a polynomial. It's a fourth degree. And it says find the domain and the range. Well, what's the domain?
All real numbers.
All real numbers. You can take any number you want, raise it to the 4th power. You're never dividing by 0 when you raise to the 4th power, and you're not taking the square root of a negative. Same thing with cubing. Cubing a number is not dividing by 0, and it's not square root of a negative. It's cubing. It's not either one of those things. So domain is all reals. Okay, range. Well, range depends. For range, let's graph it and see what happens. So we've got x to the 4th, 5x cubed, plus 2x squared, minus 8x plus 1. And I'm going to do zoom 6. It's almost a good window. It's just a little bit off. Chris, what do I need to fix here?
Zoom.
Yep, and what do I want to adjust a little bit?
The Y. Min
Yeah.
Y.
The y min.
Y min.
Let's try like negative 20. Okay, so Elias, does this function go down forever? No, it bottoms out. We have to find where it bottoms out. Does it go up forever?
Yes.
Yeah. So there's no question. The range goes up to infinity. So we know that. But the question is, where does it bottom out? Second calc, which option do you think I'm going to use? Yep. Minimum. Let's find the minimum. And the minimum to me looks like it's somewhere over here. So let's go left, right, enter. So remember, range is the y value. So the minimum is negative 11.9. That is the lowest that it ever goes. And you can put a bracket on it. It does reach it. It's showing me it reaches it right there. Okay, so the range is every number from negative 11.9 up. Now, when you say domain, that's all real numbers. Domain is how far your graph goes left and right. When you look at that, you might say, well, it doesn't look like the graph is going left and right. It is, just barely. That W shape is going to get wider and wider forever. Just barely, but it will. Okay? So that's my domain and range. I'm not going to talk too much about fifth degree polynomials. We already mentioned, they've already told us how many turns it can take. So, what I do want to look at though is these points where the graph turns. Okay? This one has a few of them as well. These points here, here, and here are called local maxes and mins. What a local maximum is it's a point on the graph that is basically higher than everything else around it. Okay? It's a point on the graph that is higher than everything else around it. Local doesn't mean it is the highest point. At this point right here, this is a local maximum. Is that the highest that the graph ever goes? No. It goes higher. But this point is higher than everything else around it. It's like a hill, right? It's higher than other stuff around it. Local minimum, it's worded pretty much the same way, except change one word. It's a point on the graph that is lower than everything else around it over a given interval. So local minimum is a point on the graph that is lower than everything else around it. So if you look at this graph, what I just circled is a local minimum. How about this? Is that lower than everything else around it?
Yeah.
Is that lower than everything else, period? This is called a global minimum. You're not wrong to call it a local minimum. It is. It is lower than everything else around it, but it's lower than everything else, period. It is the lowest point ever in the whole thing. So you can even say something a little stronger about it and say it's a global minimum. This particular graph right here has no global maximum. It goes up forever. So global means it is the highest or lowest, period. Local means it's the highest and lowest in a certain area. Now, together, when you have all the local mins and maxes, we call those local extrema. So, if you see directions on the test, or in the homework, and it says find the local extrema, that just means find the mins and maxes. That's all. All of them. So, if you had like a fifth degree polynomial, now you're talking about a lot of them. You could have something like this. You could have 1, 2, 3. You could have up to 4 things you'd have to find. A couple mins and a couple maxes. Okay? Those are called the local extrema. Okay, so let's graph that, and I'm just going to do the minimum. I could do the maximum pretty much the same way. But it's x cubed minus 4x. We'll start with zoom 6 and see how that works. Okay, so we have a minimum and a maximum. Which one is the minimum? The one on the left or the one on the right?
Right.
Yeah, so we're going to find this one. So they want to know 2 things. What the minimum is and where it occurs. And I'm going to try to make this very simple. The minimum itself is the y value. Where it occurs is the x value. Just make sure you keep those straight. So second, calc, minimum. Pick a point left, pick a point to the right, and do your guess. Okay. So what is my minimum there? Jared?
Negative 3.07.
Yes. So the minimum is negative 3.07, and it occurs when x is 1.15. I'm just getting that right off my graph. So any question on the difference between telling me what the minimum is and where it occurs? Where it occurs is an x. What it is a y. And you could do maximum the same way. Now this doesn't always happen, but in this one I think it's symmetrical. These 2 points. I think the maximum is negative 1.15, positive 3.07. Just the way it worked out. All right, so the last thing ties in with local mins and maxes. Look at this picture. I've labeled B and C, which are local mins and maxes. And A and D, they're just like endpoints, just pretending that my graph stops. What happens in this graph? Or actually, you know what, let me ask you this first. Can anybody tell me where is this function increasing? From what to what?
B to C.
B to C, yep. So this function is increasing from B to C. Notice B is a local minimum, C is a local maximum. I'm going to come back to that. Where is this function decreasing? Yep. C to D, yep. And where else? Yep. A to B. Notice again, we're using B, which is like a minimum. We used C, which was a maximum. So now, think about this. What happens to a function as you go from increasing to decreasing? Look at the graph. What happens as you go from increasing to decreasing? You always get a what? You always get a maximum. Anytime you go from up to down, you get some kind of maximum. Global or local, it depends. But you get a max. What happens as you go from decreasing to increasing? You get a minimum. Yep. So, when you have a question that asks you to describe where a function is increasing and decreasing, you have to find what I just showed you how to do. You have to find the mins and maxes. And I'll do one more, and that'll be our last one. I'm actually going to use the same graph we already used. Questions on that idea? Okay, let's try our last example. So, find the intervals on which x cubed minus 4x is increasing and decreasing. That's the graph I have on the screen already. We found the coordinates of this point. It's still on the screen. This one, if you just trust me, because I've done it before, it's negative 1.15, 3.08. So there's your min and your max. Okay. Increasing. Can somebody tell me where this graph is increasing? From where to where? Yeah?
A to B and C to D. The left, up.
So we got to use numbers here. Yep. Numbers, or if it's an unbounded interval, there might be an infinity in it somewhere.
So,
Yep.
infinite to negative 1.15.
So negative infinity. I agree, from negative infinity to negative 1.15, it's increasing. Yep. And 1.15 to infinity. There and there. Now, where is it decreasing? From? Not what's it decreasing to. So the increasing and decreasing is always the x value. Negative 1.15 to positive 1.15. That's where it's decreasing. So you just have to know how to find mins and maxes. Tomorrow we will finish up section 3.2. A lot of the homework on 149 is on the graphing calculator. So if you do a problem on there, you can just write on calculator. But we'll look at 116 and 149 tomorrow. Okay, also don't forget, I will be after school for extra help if you need anything on Thursday. And if you've got tests or anything else that you just finished, you didn't get on your progress report, but it will be updated on ASCII. Just not for your progress report, because I think those are already printed. And you'll get those probably Friday.